Probability, example 17. So we're going to continue on with what we've been doing with the incidence rates, and we're going to see what we can do without prompts. So just a way to logically work our way through this. What would make sense? So let's continue. A certain disease has an incidence rate of 0.75%. Right, so in our chart, and yes, this chart will be provided for you on an exam and your worksheets and what have you. So what we'll need to do first is figure out for this 10,000 that we are utilizing, how many people would have the disease if our population is 10,000. So let's change that 0.75% to a decimal and multiply by 10,000. And we're going to get our 75. So if 75 have the disease, then how many do not have the disease? Well, that's simple. We'll just subtract it from 10,000. Okay, then they said if the false negative rate is 15% and the false positive rate is 4%, compute the probability that a person who tests positive actually has the disease. Well, let's break down that really long sentence that is chock full of information. So a false negative would have to be someone who tested negative, so it's got to be either this box or that box, but it would have to be a false negative, so it's wrong. So a false negative would be someone who tested negative, but they had the disease. Okay? So the false negative rate would be 15% of the people who had the disease. So 15% as a decimal, 1500ths times 75. And that will give us 11 and 2500ths. And then what I can do with this information then, if a total of 75 had the disease, I can figure out how many people who had the disease tested positive. And so I'm going to go ahead and subtract 75 minus 11 and 2500ths. And I will get 63 and 7500ths. Alright, so I have my false negative taken care of. Now the false positive, by now we're starting to run out of boxes anyway, so let's just double check. False positive, so they tested positive but it was wrong. So it'd be a false positive if you tested positive but you did not have the disease. So how many would that be? So 4% of the 9,925 gives me 397. And then again, to figure out how many people did not have the disease that tested negative, we will take that 9,925 minus the 397, and I get 9,528. Okay, to get the totals of all the people who tested positive, we'll just add across. This is 63 and 7500ths plus the 397. 460 and 7500ths. Same thing with the negative column, row that is. When I add those together, I get 9,539 and 2500ths. So they asked us to compute the probability that a person who tests positive actually has a disease. So we're looking for the probability that a person has a disease, this disease given they tested positive. So let's remember that the conditional probability will change the number of outcomes. So we're looking for the 460 and 7500ths to be in our denominator. And then how many people had the disease from that category? 63 and 7500ths. Well, let's change that to a percent by multiplying by 100%. We change any fraction or decimal to a percent by multiplying by 100, putting the percent sign, and we'll get 13 and 8/10%.